Hi guys, so today we're covering lesson 5.3, which is all about using the logarithmic properties we've learned so far, and then we're going to learn a couple of new properties today as well. Okay, so for your warm-up, first question says find log base 64 of 4. So what you can do here, as we've talked about so far, is label. I always like to remember logs are bay. I know it's kind of a silly way to remember things, but log base b of a equals e, and where b is the base, a is the answer, e is the exponent if you rearrange it as an exponential. Okay, so the other way you rearrange this is base to the power, base to the power of exponent equals answer. Okay, so I would label this as B, this is A, your unknown is E. So if you rearrange this, you have 64 base 64 to the power of some exponent, which is what you're trying to find, equals 4. So how do we get from 64 to 4? Well, we can take the cube root of 64 to get 4. And remember, the cube root is the same thing as taking that number, 64 to the power of 1/3. So typically when you're going from a larger number to a smaller number via an exponent, it's usually going to be because you have either a fractional exponent or a negative exponent. So here our answer would be 1/3. Okay, same thing here. This is the B, the A, the E. So base 7 to the power of some exponent equals 7. Well, this you're going to notice is actually one of our special log properties that we learned last time. So if the base here is the same as the number here, then this is always going to be 1 because that base to the power of 1 is what gives it itself. We also learned last class a logarithm with base 10 is what we call a common logarithm. And think about our number system, it has base 10, we start at 0, we count to 10, and then we count by tens from there on forward, so that can kind of help you remember. And then a logarithm with base e is called a natural logarithm, and reminder that we denote with ln. So I like to think n for natural, l for log. Okay, so natural log of whatever, and then common log, we just write log, you don't have to write the base 10. All right, so using, let's go back here. Properties of logarithms. So here are 3 properties of logarithms that we're going to use today to expand or condense logarithmic expressions. Okay, so take a minute. If you need to pause the video here, you can do so. I want you to write all of these down. These are going to be extremely important. So first one is the product rule. Okay, when you have log of some base b of a product here, where you have some number times some number, m times n, the way that you can split that up is into 2 separate logarithms with that same base, so they both have base b, and you have log base b of the first number plus log base b of the second number. So you split up what's on the inside, the m and the n, and you add those logarithmic expressions in the middle. So that's what product rule is. And you can go back and forth between these. So if we are wanting to expand, that means make it bigger. You would want to expand it into 2 expressions. If we want to condense it, that means make it one tiny logarithmic expression. We would go to this on the left. Okay, quotient rule is what it sounds like. So when you have the logarithm of a quotient, meaning dividing one number by another, you can split that up with subtraction. So log base b, same base, it has to be the same base for both of them, of the first number in the numerator minus log base b of the second number in the denominator there. Okay, so another way I like to just think about this or remind myself of how to do this is when I see this division symbol, I always think, okay, that can become a subtraction symbol between the 2 log terms. And then power rule is the third rule that we're going to use today. So whenever you have log base b of some number m to the power of some other number p, we can rewrite that and take that power, that exponent, and multiply it out in front of the entire expression. Okay, so you can move this exponent out in front to multiply times the whole thing, or vice versa. All right, so once you've gotten these copied down, then we're going to go ahead and apply them. Okay, the first examples are to expand each logarithmic expression and simplify if possible. Again, remember, expand means to make it larger. So we want to make it as large as possible and as expanded as possible. So anything that we can separate, we're going to separate. So here, I'm going to notice I have log base 6 of 7 times 11. That is product property. And you don't have to write that always, but for now, I would just do this just as a reminder. So product property says we split these up into two separate expressions, so log base 6 of 7, and then I'm going to separate them with a plus sign, plus log base 6 of 11. Okay, second one, this is a common log because you have just log, you don't see the base, so the assumption is it's base 10. And we don't have to write that, of 100x. So this is also product here, even though it doesn't have a multiplication symbol in between there, because 100 is being multiplied times x. So we can rewrite this as log of 100 plus log of x. So just separate it like so. And then log of 100, because that is actually something that we can go ahead and simplify a little bit further. If you notice, again, this is base 10. And we're trying to figure out, okay, 10 to the power of what gives us 100? Well, 10 to the power of 2 gives us 100. So log base 10 of 100, I can look at that and pretty quickly see, oh, that's actually going to simplify a little bit further. And so that would just give me 2 plus log base 10, or just log of x. Okay, so that's what it means when it says simplify if possible. Any of these that are going to simplify nicely, we want you to go ahead and do that. Versus like here, this is 6 to the power of something is 7. 6 to the power of something is 11. Those are not going to be nice, neat numbers. So you're just going to leave it in that format. Okay, so we just used product rule to expand. Now we're going to use product rule to condense, so going opposite direction. So now, when it says condense, it's wanting you to write this as a single logarithm, meaning here we have 2 log expressions. We just want it to be 1 log expression. So always, 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 you have to check for the same base. So I am even guilty of this when I am just going through and doing these log problems. A lot of times I'll be going through pretty quickly and I will forget to look to make sure they have the same base. So please double check that first, because if not, then you cannot combine them. Okay, so we've got log of 25 plus log of 4. The base here is 10 because these are both common logs. Okay, so we're going to combine this to get log of 25 times 4. So that's what product rule says. You take the insides, you multiply those together. And then log of 25 times 4 is log of 100. And again, this is our previous example, so this is a base 10. So we're looking for 10 to the power of something equals 100, and 10 to the power of 2 is 100. So that is what our answer is here, 2. Which is awesome. So this one simplifies nicely. All right, double check here. They've got the same base, they do, so both base 8. So we get log base 8 of, now we find the product of 16 times 32. Okay, so this is going to be one that you probably would need to plug into your calculator. So 16 times 32 is 512. So log base 8 of 512. And then we're going to see if this simplifies. So we're looking for 8 to the power of something equals 512. And when you're doing this, don't worry, I don't expect you to know this off the top of your head. What I would expect for you to do is plug some of these values into your calculator. So try, 8 to the power of 2, 8 to the power of 3, 8 to the power of 4, etc. Okay, so 8 to the power of 3 is 512, and then as soon as you find that, you're good and you've got your answer. All right, now let's use quotient rule. So using quotient rule to expand. Now we've got our quotient here, we've got log base 8, and remember when I expand, I take this division symbol and I make it a subtraction symbol between the two expressions. So log base 8 of 23 minus log base 8 of x. 8 to the power of nothing as a whole number is going to give you 23, so that would give me some weird decimal. So I'm just going to leave it in this format, and then 8 to the power of something is x. We don't know what that unknown is, so same thing here. Okay, now we have natural log, so natural log of e to the power of 5 is what this would become, minus natural log of 11. Okay, and then natural log, remember, this is base e, and this is one of our special cases or special properties we talked about last class. When you've got the same base here, and then you've got that same number next to it, and you're taking the log of that, those in essence like cancel each other out, and you're just left with the exponent here, okay? Because this is saying I need e right here to the power of something to give me e to the power of 5. So what is that unknown? That would be 5. So this just is 5 minus natural log of 11. Okay, now let's use quotient rule to condense. So we are going to go the opposite direction. We've got both log base 10, common base here, or common logs. So we get log of 7x plus 6, all of that in parentheses times, or sorry, not times, all of that divided by x. Okay, so quotient, remember, we take this minus sign, that becomes a division symbol in the middle there. And we just leave that as is, unless it can simplify any further. Okay, and then here we're going to combine these using a couple different rules. So whenever we have multiple logarithmic expressions, we're combining them, we work our way left to right, just like you'd read a book. So first, let's combine the first two, double check we've got all the same bases we do. So this becomes log of base 4 of 3 times 2, and 3 times 2 is just 6, okay, minus log base 4 of 6. And if you notice here, log base 4 of 6 minus log base 4 of 6 is actually just going to give me 0, okay? So at this point, you could really stop. The in-between step here would be to write out 3 times 2 minus log base 4 of 6 here. Okay, or if we were combining this using quotient property, we could rewrite this as log base 4 of 6 divided by 6, which is log base 4 of 1. And this is one of our other properties, okay, which says anytime you've got 1 right here as the number you're taking the logarithm of, that means your exponent's going to be 0, because 4 to the power of something, or any number to the power of something that gives you 1, has to be 0. So again, here you could just see, okay, these are the same logarithm. I can just stop. That gives me 0. Or if you went about it the long way and you did all of this work, you're still going to get 0 at the end. Okay, so a number of different ways to do that. And that's the cool thing about logarithms and log properties, is that all of these problems are going to have multiple different ways of simplifying, expanding, condensing, all that. Okay, now let's use power rules. So we are going to expand each of these. So I'm going to take the power, move it to the outside, so I get 9 times log base 6 of 3. Okay, here I'm going to do the same thing. So I move this out in front. So 2 times log of x plus 4. And so it's on the outside of the whole thing, which means I can just move it on the outside of the whole thing here, but with multiplication. Now, when you see this radical symbol or any sort of radical, square root, cube root, fourth root, anything like that, I want you to convert it to a fractional exponent. So that's the only way that we're going to be able to expand this. So this is the same thing as x to the power of 1/3. Okay, and then I can take this becomes the power out in front. So 1/3 times natural log of x. So you definitely will see radical symbols pretty frequently, and that's why you need to just be aware you're going to rewrite them as fractional exponents. Okay, going the opposite direction, so write it as a single logarithm and condense it as much as possible. So now the power is on the outside multiplying. If we write it as a single logarithm, that means like you want to start with log of something, not 2 times log of something or 2 times natural log of something. So this would become natural log of x squared. Okay? And then this, if I move this, attach the exponent, this becomes log base 5 of 2 to the power of 3, which is also the same thing as log base 5 of 8. Now, I will say if you have something like 2 times natural log of x plus 1, please make sure that when you move this power, you are moving it to the outside of that parentheses to ensure that you know that you are squaring this entire thing, okay? Versus this is just squaring the x, this is just squaring the 2, it's that one single term. But if you have anything else inside of here, that parentheses, you need to make sure that that exponent is for sure on the outside. Okay, now let's put all of these properties together. We're going to expand this as much as possible using product and quotient and power property, okay? All of the above. So it says first apply product and quotient rules, then apply the power rule. If we had a power like on the outside here, we would want to do that first, but because we don't, we're just going to deal with the fraction first. So we're going to do quotient property first, okay, to split this up. So this becomes log base 5 of square root of x, and then all of this minus log base 5 of 25y cubed. Okay, so I just split up the numerator and denominator. All right, so now I am going to rewrite log base 5 of, so this square root symbol, I'm going to rewrite that as x to the power of 1/2. Okay, because I know that I am going to want to get rid of this radical symbol and make that a fractional exponent. And then the other thing I'm going to do is I'm going to split this up. Let me draw this in a different color here. I'm going to split up this product. So I have 25 times y cubed here. So this is going to be minus this whole thing, okay, log base 5 of 25 plus log base 5 of the y cubed. Okay, so here's the 25 and here's the y cubed. That's where they went. And again, notice here how I am working my way left to right, but also you need to make sure that you have brackets or parentheses outside of this whole thing because you are subtracting this entire quantity. And if you just put the minus sign out in front of this without parentheses and this is a plus sign, then that's not actually accurate. So it is minus that entire thing, okay? So then we're going to use, let's see, quotient or power rule next. So I'm going to take this, move that out in front. I'm also going to take this and move that out in front. So I'd get 1/2 times log base 5 of x minus this entire thing. So log base 5 of 25 plus, this becomes a 3 log base 5 of y. Okay, the other thing you could do at this point if you wanted is you could distribute this minus sign out in front of both of those. If you want to get rid of that extra set of brackets, that's totally fine. Okay, so now we're going to try to see, can we simplify things at all? Well, I look and I see, okay, this one's got a variable here, this one's got a variable here, but log base 5 of 25, I can simplify this because if I'm looking to see 5 to the power of what gives me 25, I know that that is going to be 2, 5 to the power of 2. So log base 5 of 25 is just 2. Okay, so this becomes 1/2 log base 5 of x minus this whole thing, 2, okay, plus 3 log base 5 of y. And then if I wanted to distribute this now, I'm going to. So this would become 1/2 log base 5 of x minus 2 minus that whole thing, 3 log base 5 of y. And then I cannot simplify this any further. I've expanded it as much as possible into as many separate logarithmic expressions, and then I've also simplified whatever I can. And again, here you could have distributed this negative sign at the beginning, or you can wait till the very end. Totally up to you, whatever seems less messy. Okay, let's go the opposite direction, and then we've got one more property to learn, and we'll do a homework problem together. So the other direction, we're going to condense these expressions into one logarithmic expression. So we've got 5 times log base b of x minus log base b of y plus 1/4 log base b of z. So now it says apply power rule first. We're going the opposite direction, then product and quotient rule. So we cannot combine logarithmic expressions, even with the same base, if they've got these powers out in front. So you have to make sure that you just have log of something plus log of something minus log of something, no numbers out in front. So we're going to move these powers right here and right here to become the exponent. So this would become log base b of x to the power of 5 minus log base b of y, that one doesn't have a power, plus log base b of z to the power of 1/4. Okay, so here's the exponent, here's the exponent. So we did that power property first. Okay, so then what we can do is we can move left to right to try to combine these. So first I'm going to use quotient property here with these first two expressions. So log base b of, this now becomes x to the 5th power divided by y, all of that plus log base b of z to the power of 1/4. Now z to the power of 1/4, I'm going to rewrite this as the 4th root of z, because when we are trying to condense this, we want to make it a little bit simpler and get rid of that fractional exponent. So then to combine these, I multiply the insides using product property. So this times this. So log base b of x to the power of 5 divided by y times 4th root of z. Okay, and that's not going to simplify any further, so we can leave it in that format. Or you could always move this into the numerator, because this is the same thing as that divided by 1. However, I'm just going to leave it in this point, just because this was tacked on as the third and the last logarithmic expression here. Okay. All right, change of base property. So sometimes we do need to change the base in our logarithms in order to get decimal approximations using a calculator. And most calculators, well, I would say most advanced calculators are able to plug in logarithms of any base. However, scientific calculators and more basic calculators only operate in base 10 or base E with natural logs. So it's super helpful to have a formula to be able to change the base to whatever we might need it to be. So this is that formula. Please, please, please write it down. So when you have log of some base b of another number m, to change the base, this is what we write it as, a fraction, okay, where a is the new base that you want. So a is the new base. And so you take log of that new base of m, this number, divided by log of that new base divided by, of b, the original base. Okay. All right, so using this really quickly, we'll just go through one example so you guys can see what this looks like. So it says convert the given logarithms to common log, which is base 10, and then calculate using your calculator and round to the nearest hundredth place. So we'll have log base 7 of 2,506. So we rewrite this as log base 10. We want base 10. And we don't technically have to write that because it's a common log, so it's assumed, of 2,506, so this number first, divided by log of base 10 again, of the original base 7. So then in your calculator, you would just pull this up. I'm going to show you guys real fast. The log button is typically over here to the left side, so plug in log of, whoopsies, this number. Let me delete that. Okay, that's not gonna work. Log of 2506, close parentheses, divided by log of 7, close parentheses, and that log button on your calculator is a common logarithm, okay? So it's about 4.02. And the hundredths place is 2 spots after the decimal, so we'll leave it like that. All right, and then the next one here, so log, we want base 10 again, so of 8,560, first number, this is this one, divided by log base 10 of the original base 5. So let's plug that in, 8560 divided by log of 5. Okay, which is about 5.63. All right, and then you can do the exact same thing here with converting these to a natural logarithm, so base e. So all we would do is we would rewrite this as log base e, or log base e is the same thing as natural log, so natural log of 2506 divided by natural log of the original base 7. Okay, and if you plug that into your calculator, you're just going to use the natural log button. So natural log of 2506 divided by natural log of 7. Notice it actually gives you the same answer. So pretty cool here. Okay, so 4.02 approximately. So same answer as when we had base 10. Because notice we're starting with the exact same expression here. So if we convert it to any other base, it still should be equivalent to what we originally started with. We're just rewriting it in a different way. And so then we would do the same thing here, natural log of 8,560 divided by natural log of 5. And then we plug that in, and you're going to notice we get the same thing as we did before, which is 5.63 approximately. So it doesn't matter which base you're converting it to. It's going to give you the same answer regardless, but it's super helpful to have this formula so that we can convert to base e to where it's a natural log, or base 10 to where it's a common log, because then we can plug it into pretty much any calculator, usually including your phone calculator. Okay, so this is the homework for today. I do want to do problem number 57 with you guys real fast, just because that one is a little bit challenging. So I will finish that with you guys, and then you guys can get working on the rest of it. All right, so problem number 57 says simplify using the properties of logs. You've got log base 9 of 1/18. So this one initially doesn't look like a hard problem. However, I'm just going to show you guys it can actually be simplified again and again and again, multiple times. And so I'll show you kind of how we do that. Okay, first thing I'm going to notice here is that I've got a quotient inside. So I've got log base 9 of 1 divided by 18. So I'm going to use quotient property first to split this up into log base 9 of 1 minus log base 9 of 18. Okay. Now, the key thing that I want you guys to do here, in addition to using power, property, product, and quotient property, is also to look for all of those special properties that we talked about last class and that are on that formula sheet. So if you notice here, this first one is one of those special properties. Anytime you have a 1 here, you're taking log base anything of 1, that is actually 0. Because remember, if I take this base 9 to the power of something equals 1, that number has to be 0. So I can rewrite this as just 0 minus log base 9 of 18. Okay, and then that just gives me, if I write this over here, negative log base 9 of 18. Now, a lot of people would stop at this point. However, I want you guys to be really careful. Anytime that you see a base 9, okay, and that base goes into or factors into the number that you're taking that logarithm of. So we know that 9 goes into 18. You're not done simplifying. So that's something that I want you guys to start looking for in your homework today, is double check to make sure, does that base actually go into the number that we have here, which it does. Okay, we know 9 to the power of something equals 18. Okay, that's what this is. However, that's not going to be a whole number, but we still can simplify it further. So if I split this up, I can rewrite this as negative log base 9 of 9 times 2, because I know that 9 times 2 gives me 18, okay? And the reason I would do this again is because I'm looking to see that, hey, there's a common factor. 9 goes into 18, okay? So we're going to split it up like so. And then looking at this is product property, so I can now split this up. So negative, I'm going to put a parentheses out in front of the whole thing because the whole thing's negative. So log base 9 of 9 plus log base 9 of 2 if I split that up. Okay, so I'm just separating the 9 and the 2. The reason that I'm going to do that is because, again, I notice a special property here. When you've got log base something of that same number, so same base, same number, that is always going to give you 1. That's another one of our special properties. And if you don't remember that off the top of your head, just take a look at that and see, okay, 9 to the power of what gives me 9? Well, 9 to the power of 1 gives me 9. So if these two numbers are the same, that gives you just 1. So then we are left with negative, let me put this out in front, okay, negative, parentheses, just 1 plus log base 9 of 2. And then if I distribute this negative sign, I'm going to get negative 1 plus, sorry, that would be a minus sign, negative 1 minus log base 9 of 2. So you could stop here. This is pretty simplified, or you could actually keep going even further, and I want to show you how you would do that, just because there are multiple ways that you could continue to simplify this. So this minus sign out in front, that is the same thing as having a minus 1 times this whole thing. And if I took that minus 1 and wrote that as the power, I would have negative 1, and then this would become a plus log base 9 of 2 to the power of negative 1, okay? This is, again, this is not something you have to do, but I'm just showing you how this could be simplified even further. And then 2 to the power of negative 1, I could rewrite as log base 9 of 1 over 2 to the power of positive 1. And then even this would turn into another quotient here. Even this could then be simplified and split up into negative 1 plus log base 9 of 1 minus log base 9 of 2, etc. Okay, so we're trying to simplify this as much as possible. So this is kind of expanding that back out. But I just want to show you that a lot of times these log expressions, you can rewrite them and manipulate them a ton of different times. The key thing here, though, that I want you guys to notice and that you need to start doing in your homework is what I said up above, that you need to look to see, does that base multiply into that number next to it? And if it does, then you need to rewrite that number, split it up into those factors, and then continue to simplify. Okay, so that's number 57. The rest of your homework, like I said, is here. Ask if you have any questions.